So what you will get after you finish your chapter 5? One, you can determine the ration order, meaning the alpha, and the specific ration rate, meaning the K, from experimental data obtained from either batch or flow reactors. And then you can also describe to use how to use the equal area differentiation, polynomial scalar, numerical different formulas and regression to analyze experimental data to determine the red law. All is about to determine the red law. Why you have to determine the red law? If you remember the table, in the table chapter 1, chapter 2, there is many mole-Barrett equation that let you to calculate the finally the V. So in finding the V, on the way to, you have to know the details of the red law. Then to kembangkan dengan stoichiometry. Okay, that's why you have to know about the red law, the alpha and K. And then you can describe also the how to find out that one by using third objective methods of half-life, initial rate are used to analyze the data. Ini yang new for you, half-life maybe. Okay, finding the red law. Orang vision or construction. Consider the following reaction that occurs in a constant volume batch reactor. Constant volume batch reactor. We will withdraw samples and record the concentration of A as a function of time. Okay, let's begin with the A to product or A to B. Okay, the because of the constant volume batch reactor, so the mole balance is like this. Okay, then mole balance is like this. Betul ke ni? Betul lah. Betul red law dia. We don't know the order, so we don't know the K. We just put the red law. We get negative RA equal K CA power of alpha. Okay, and then stoichiometry because batch is maintain the volume. Okay, V equal V naught. And then when you combine all this one in this one, you see DNA over V. If you move the V to here, DNA over V equal DCA. Then over DT equal negative RA. Negative RA meaning this one. That's why they substitute meaning this one. You got it? Senang kan? Okay. Then from that, you got this equation negative DCA over DT equal KCA cos alpha. Okay, you got it, and then you can put it into log. Taking the natural log is like this. Okay. Then when you learn this one, you can get y equal mx plus c. Okay. You can see the y equal ln negative dca per dt, x equal ln ca. So the m is equal alpha, and when you got the alpha, you can find out the k, which is c. Then the ration order can be found can be found from a ln ini if you use the ln graph. Kita tak perlu ln ni, ini kita log, kita guna log, kita kena ln ni. Kalau nak guna yang ni, dia cepat jalan. Okay. The order can be found from a ln plot graph, dca over dt, vsca. Which graph? You can put in this graph. Pokoknya cepat sangat ni. Okay. Have you seen the graph that the pattern of the graph is different? The usual graph, the peta is same, the pattern. The size of the peta is same, but some there are another graph that is the apa peta dia besar betul kecil 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 besar kecil 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 ada tak? Can you remember that type of graph? That you can use that graph without using long. Okay, you can put the this one, the value of this one and this one directly to that graph if you use that graph. Okay, but if you use the usual graph, you have to learn lah, learn macam ni yang tadi ni perasan ni learn DCA dia punya Y, ni dia punya X learn CA. Kenapa sensitif sangat? Okay, that's why you see ln DCA per dt adalah Y ln CA tu. When you put all the points, you can draw the straight line and then you can get the slope from the M kecerunan kan, Y per X kecerunan, and then the K you can get from the here when they touch the Y axis, you can get the K ln K tadi kan. K and then epsilon kan dapat you can get the K different. Okay, that is from graph. However, we are usually given concentration. Okay, usually they give you concentration. You have to know the unit. Okay, if you do not know the unit, trouble lah. Okay, concentration and as a function of time. For batch system like this, usually they will give you a set of data. Like I said, this is one example. The set of data concentration within time. Okay, for example. Then three ways can determine the negative DCA per dt from the concentration time dengan data ni. Satu graphical, dua polynomial, tiga lagi finite different. Finite different pun calculation. Why you have to determine this one? Because why you want to plot the graph and dCA over dt tu to find your alpha dengan k. Okay. Okay, this is the example for the graphical. When the question, exam or test say you the graphical or do not say the graphical, but it give you the graph, so you have to use the graphical method. Okay, graphical method. Here you can see we have two graphs. This graph is the graph with the DCA over T. Okay, this graph, if you see, this is not D but what? This triangle, call it what? Hello?
Delta.
Delta. Okay? Delta. This is D. Different. This is delta. Jadi negative delta CA over delta T. This is T. Okay? Saya tunjuk. Okay. If they give you the set data like this, first time you have to write the graph with the delta. So you have to know the delta T and also delta CA. Delta meaning this, for example, delta 1, this minus this over this minus this, right? Delta CA over delta T. And then you can, when you get the one, you can draw this, what you call it, histogram. Okay, from the delta graph ni, you can draw a histogram. Okay, when you draw the after you finish draw the histogram, you have to put a line or a line, mostly like this on the top of the histogram punya peta ni. But you have make sure to be accurate. You have to make sure that the point of the curve that you make touch the center of this top of the histogram. You see, it's not easy to sometimes you can get the bagai ular di palu punya line, bengkok-bengkok. Okay, but please get the smooth one. Here to here, the best one touch the center of this one. You see, they can do it. Why you have to get the center one? Because you have to read the y-axis from the center ni bawa ke y-axis. You have to read the y-axis. For example, this one. You see, this is the histogram. Oh, bukan tengah nak, yang tepi ni. This is the histogram. You have to put the graph, make it the graph touch the apa center. This is not the center, right? But if you can do it, better you do, because you have to read this one, the bullet one. All the data you have to collect to plot the next linear graph. Okay, so this is the 0, 1, the negative dca over dt at point at t equals 0. This is the point for negative dca per dt at time t1, and continue this one the at time t2, and continue lah, and then you can get a set of data. Okay? Why you have to get a set of data? Because you see the ln is in negative dca per dt, not negative delta ca over dt, right? Not delta but d. Okay, after you plot it, and then you got the point, and then you tak tunjuk, it's okay. After you got this one, you have to learn lah. You have to learn all. So your table will be, you have to do once again. Here is about dca over dt, and then the other one is ln dca per dt, and then you put with the dca per dt times ca. Okay, then you can get the straight line, the dca dt from the you got from the histogram and the previous graph. Then you plot another graph to get the alpha and k. Do you understand? This is important method when they want you to use the graph. A question. Okay lah, the question. That is the graph, okay? Next, polynomial using polymath. Don't know whether you got the computer assignment or not from the Taja. Hello? Hello?
Not sure, doctor.
Not sure. Dr. Tahir will resign, and then another new lecturer will replace him, maybe from January. Okay. With tough question from Dr. Tahir, you are safe, huh? We don't know Dr. Tahir anymore. Okay. Okay, polynomial is about this. I don't know, but this is using polymath. You put that one, and then you get dn and dca per dt. Then the polynomial, because of using polymath, so will not appear in the test or exam. This is another one, calculation, finite difference. If you see the textbook, you can see numerical method, I think, in the chapter 5. It said numerical method. Numerical method is meaning you have, I do not show here. If you see the numerical method or finite difference in the textbook, you can see there is a formula for the beginning. See the beginning, I think. The beginning start point, then point one, I mean point one or point zero though. Point one punya equation, then at end point, last point that you will get from the set data, then the between the first and the last one, the equation is different. Okay, I think this is the center one. Okay, you have to calculate by using this one. Then you can get the dca over dt. This also same, just for the dca over dt. Like this one, you have to use the histogram to get the dca per dt. But this time you just calculate how to get the dca per dt, and then at the same time after that you have to plot the straight line graph, get the like this one, get the line graph, get the column k. Okay, so that is about the differential method. Okay, we have three types of differential method: this graph, polynomial, and also finite difference. Sometimes the question do not mention whether you use finite difference or apa nama dia, graph. If the question do not say, then I think if you familiar with the finite difference, you can go with the finite difference. Okay, but you have to plot also the glass graph, the straight line graph. Okay. Okay, this is the second method. After differential, in differential we have three methods, and then this is the other friend of the differential, which is integral method. Finally, we should also use the formula to plot relation rate in terms of relation with time for first, second, and order relation. Okay, this is the derivation equation used to plot zero, first, and second order relation. Okay, see the table. Sama je tak? If first order, use this one. Second order, use this one. This is the overall Mavericks equation untuk batch. Then this is, you know about this. Just substitute when you combine this one, negative RA and negative RA. Itu equal negative RA. Negative RA equal KCA per DG. So you got this one. And then when you put it into, oh, this is T, okay, T, okay. Then the second one, same, you have to put inside the for example, negative RA, put this one, do like this, same one. Then you can get the combined one, ini equal KCA power of 2. Same but the T is like this one. Okay, to differentiate, you get the T equal this one. Ni differentiate, okay, dia dapat ni. Okay, that is integral method. Okay, in differential method, you have to calculate the graph, or you can do different calculation. Then you have to plot the graph y samaan mx plus c. But the integral method, you just assume. Okay, we have three order, right? First order, second order, and zero order. Okay. So if you, this is just for gamble, you play with time. When you assume that question, the data given in the question is zero order, you just go with the zero order graph. This is zero order graph, okay? Negative DCA for dt equal negative RA, no CA. Remember, concentration dia adalah okay, tak apalah. Okay, DCA over dt equal RA. So you plot the graph, okay? If you get the graph is linear like this, so meaning that the question is zero order. Okay, if you get the not linear, the curve not linear, so that your answer that that is the zero order equation is incorrect. So when you do not get the straight line, you have to go for the next assumption, that is first order. For first order, the just what the y-axis and the x-axis is different. The y-axis is like this. Okay, if you want to derive, you can derive, and then you can get the first order. Dia punya y-axis is like this. Okay, you can see here. This is so y equal mx. M adalah t. So just t sini. Dapat slope, dapat k. Okay. If you assume that direction is first order, you will plot this graph. Okay. Then when you get the line, a straight line, is okay. That is the exact answer for you. But if you still not get this is playing with time. Not get the zero order, still not straight line. Second order, still not straight line. Meaning zero first and second second order. Okay. When you have to assume the second order. Second order, the plot is like this. So this one, y equal mx plus c. Y dia yang CA, T turunan dia, and then you can get that one. Okay. Boring ke? Boring je seorang. Faham tak tadi? So we
jadi doktor try and error je kan kalau guna integral.
Yeah. If the question asks you to use integral, you just use try and error. Zero, first or second, using the equation given in this note. Okay. And then when your answer is correct, the straight must be straight line. Okay. So now,
Okay, doctor.
okay. Now you know two types of calculation, which is differential and integral. Okay, to get alpha and k. Okay, self-test. What two things are wrong with the solution? The solution A plus B equal to C is carried out in orthogonal batch reactor. Determine the reaction order and split reaction rate from the data. Macam nak buat dia? Set of data, what you have to do, dapat this one, okay? So you replot, you put in the table, you got this one, the table is panjang buat. Dia bagi T dengan CA only, this only. And then you have to calculate for this one, for this one, then you can get by the graph what is this. Sebab A ke CA, ni mobile equation lah, awak kena rearrange. Then you got negative RA equal dCA over dt. Okay, then okay, to find the dCA per dt, how to find the dCA dt? Like I said before, they use the histogram. You can use the histogram if the histogram is the same interval tau. Kalau different tak boleh juga. You see, this is same. 10, 10, 10. Okay, you can put like this histogram. You draw the curve and then you get this one. This is the the dCA per dt over dt for 0.05 meaning at t equals 0. Okay, this is t equal, this is dia tak ambil yang sini, dia ambil yang sini pula. Letaknya kat sini dia ambil dan sini tau. Ni yang ini pun ni betul lah ni, dia sentuh kat dinding tu kan, betul. Then ni what's wrong with this solution tau, then dia bagi solution dah ni. Now dia orang tu dia dapat dia plot, dia dapat dia siapa dt, dia plot graf biasa. Dapatlah straight line, dapat 1.67 dia punya slope. Then apa dia punya K dia tak cakap. Okay, the plot is essentially linear, therefore the direction is zero order, dia kata. From the slope of the line we can find, dia kira lah K sama dia. What's too wrong with this solution? Hello, satu. Betul ke cara dia? Betul caranya? Tak jawab dah lah. Dua benda yang salah adalah satu, dia kata. Graphical differential of the data is incorrect. The dCA per dt is plotted as a function of delta CA. Bukan versus T. First, even the data of Persia versus is not plotted correctly according x-axis must be time, not dCA. Ni dia kata salah. Sebab kat sini must be T Satu belum. T kan? You see? Negatif dCA over T lawan dengan T. Kemudian baru benda ni lawan dengan T juga. T1, T2, T3 je tu. Faham? Okay, paksi Y dia mesti delta CA. Satu. Lagi satu. Lagi satu to the plot to determine direction order and second order and rate constant is incorrect. Kenapa? But combine mobile equation dia mesti dapat macam ni. Kita kena learnkan dia. Ni lah. dCA over dt. Dia tak, ni untuk histogram. Dan untuk lukis, dia tak buat. dCA per dt over time. Betul kan? Buat plus CA lah. Plus non CA dia tak ada. Kan? Betul ke Iqmal? Apa yang salah ni? Plot learn distributed versus CA or plot DCA versus CA and log ni log graph paper determination order. The correct plot adalah seperti ini dia kata. Ni lah log graph tu. You see the difference between the one to another. This is far away and then this is very near. So jarak dekat makin dekat. This is what we call it log graph. If log graph, you do not have to learn. You just put the value, okay? Usually depends on the pemeriksa dia nak bagi awak plot graph ataupun graph biasa. Tapi usually they will give you the graph biasa, right? So you have to learn this one. Get this one. Question? If any question, we go next. Integral method of analysis of pressure time data. This is an example from the old book. They do not use the concentration, but they use the P. You see? Dia suruh guna integral method, dia suruh dapatkan K dan juga alpha pada tetrabutyl peroxide decomposition. Okay? So you can see they do not use the C, but they use the P. Because of what? I think because of the data is P. Okay, not C. P is pressure, so P equals CRT, and you have to remember. Okay, okay, dia nak integral, dia try and error. As a first guess, we might try zero order. When zero order, the equation, this equation become like this. Okay? You got it? Hello? Ya Allah, tuanku tak ada orang jawab. Dengar tak?
Dengar doktor.
Then you got this one. Okay, and then the plot. This is zero order. Dia plot macam ni dapat ni curve tau. Bukan garis lurus. So, ni salah. Have to put draw another graph. So, dia assume yang kedua dengan second order pula. Dia assume yang second order dia dapat graph macam ni pula. Lekuk juga ni. Curve juga. So, this is not the same. Not the second order. First order pun bukan, second order pun bukan. There must be another one is zero order. Okay, zero order you got this like this one. This is the example lah when you use integral method. Okay, this is the last one method which is they also calculate. This is half-life method. Okay. What is the half-life duration? Time it takes for the concentration of the reactant to fall to half of its initial value. For example, 10 at 100, and then the half-life is about this is about when they fall into 50% of the volume. By determine the T setengah, you can get the ration order and K. This also from the graph. For example, this graph, this is the general graph to get the K and alpha CA. Okay. So by integrating with the initial concentration CA equals C naught, when T equal 0, we find that this one. Dah habis. So you have to calculate the T. The T is equal from this one. Okay. The complicated one you have to do. This is T tau, belum ln lagi. So if you want to put in graph, we have to ln T equal MC plus Kn. This one. Then okay, this is the equation when T equal this half, the Ca occur equal over half juga. Then you got this one, you subtract in this equation. Okay, and then you put in the ln graph. Ln equal, so this graph cannot do kan without anything. To ln. This is ln ln, and then you get this one. Okay, so the graph is like this, different Tadi perkara turun dekat ada sengsang. And then you can get the, you panjang kat sini, you can get the note ya kan? Tadi kena clear dah. Finish already. Phone ni. Stop. Jangan. Okay, that's all for chapter 5. As a conclusion, this is a chapter to calculate for the K and alpha. How to calculate? There is three different methods, which is one is differentiation method, two is particulation method, three is half-life method. Okay. Polynomial also for if you get the question, read the question properly, then you can know. Okay. The question is what is the question, where you have to write, read carefully. Okay. Interesting tapi apa itu half-life? Half-life adalah T equal T half. When all the overall initial concentration become half. That is the C. When you derive, we got this one, the yellow one. The yellow one used here. Just put the scope and alpha to get the equation. That's all for today. Any question? Jump again. Reaksi kita bila ni ya? Ujian tak tahan lagi. Buat lagi kan? Any question? Dah faham semua Faham semua dah lah. Tak ada question. Nak proceed chapter 6 ni. Okay lah. I think I stop here. If no question. Can I stop here? Next, we go for the question and answer for the chapter 5. Sebenarnya saya baru keluar hospital semalam. Okay, setelah 6 hari di clinical. Ni makan ubat ngantuk lagi ni. Saya MC tak ada kelas. Kita tinggal syllabus kan. Gagahkan workshop yang dalam chapter 6 nanti lah kita belajar chapter 5 je dulu. Okay. Okay, from Wednesday prepare for the question. Okay, not same question, not similar, other than other. Okay. Okay, bye bye. Dengar tak?
Dengar doktor. Dengar doktor.
Okay, bye bye. Nak makan ubat lah. Bye bye.
Thank you so much doktor.
Welcome.
Thank you doktor. Get
Yeah.
well soon.
Thank you, Doktor.